Yes, it is that. Right now, that is, we are going to see the embedded systems. Embedded system till now, that is the this is our syllabus. So that is a till now we are covered the introduction to embedded system, build process of a embedded system, next structural units of a embedded processor. Okay, now today class we are going to see the selection of processor and memory device. If it is time permits up to DMA, direct memory access. I think the concept of DMA you are studied in the microprocessor and the microcontroller. Same thing as here used, but this is something else differ for software based DMA concept, how we are going to implement in the OS or embedded OS based systems. Okay, right. Today now we are going to our original session, that is the selection of processor. The first today title is called that the selection, how the processor which can be selection for our embedded systems. So the we are going to consider the different categories. We are going to consider the basic different categories of this selection of processor, right? So the first one is, that is the performance of characteristics. So what is that performance of a characteristics? Next we are going to that our whiteboard session. Here, that is the selection of the a processor which is available, a processor which is available, that is in that different category, right? Different categories. So how we are going to be analyzed, that is the what is the different categories, what is the bit, what is the bit size. So that is bit size means what is the size of ALU, arithmetic and logic units. Next, that is the speed of operations. So next one is, that is that if you want to select the processor, bit speed, what is the speed. Next one is that is RAM and ROM, which is may going to called as, that is the memory. What is the memory is required. So these are all the things, that is performance characteristics. Next one is IO ports, that is IO ports. Next one is that is that IO ports, everything is available. We are going to increase, that is the number of things, depends upon the requirement. Suppose now we are going to consider, that is that the basic characteristics of that the systems. So the performance considerations. So that is what is the performance we have going to be considered in the different categories. So what are the categories? Performance means which can be the, as per the embedded operations, that is the speed. Next one is, that is the bit size. What is the bit size and speed? Next, that is that already I have sold, that is the ports, that is ports, how input output ports, how we have going to be considered as etc, right? So that is we are going to be consider. The final session I am also going to conclude to you. I am also going to conclude to you how which can be differentiated with each other. Next one is, that is the power considerations. So that is the power. So if we are used in that the power consideration, power, suppose if your system used in the typical process, some other that is battery storage system, that is battery, or it can be get that directly from the grid. So that is the different criteria we are going to be considered. Suppose if we are used in the mobile, that is the mobile operations, so we are going to considerably very low power consumption of the processor. It is very significant for the low power operation, because if the power consumption is more, then we are going to directly increase the battery. It can be incorporated is a function of battery. If the battery ah, then if the battery ah is a function of also a cost, so we are going to take an as a optimum selection with respect to the power. So suppose if you are mobile, we are going to take an as something. Sometimes I am also going to select the controller, the same types of controller which may be in drive, which may be in drive system, that is power electronics based drive system. That control board which may be connected the power from, that is we are getting the power from that grid. There is no problem, that is power from the grid, there is no problem requirement of that power. So here the power consumption is that is how much of the power is consumed by the processor. So that is the another one point. Okay, are you able to hear my voice and clear my screen?
Yes, sir.
Yes, right. Next, peripheral instruction, that is a peripheral set. So this is important thing. Peripheral set which may be come under the that is the concept of IO ports. Okay. Suppose a processor, or a controller having a that is ADC, we are directly get the signal from the sensors, which is easy. Okay, suppose is if the IO ports, that is there is no ADC, we are additionally going to put to the ADC. Additionally, we are going to be add to the ADC. So what is our application? Based on our application, this is which one is based? That is based on the applications. So that is application, for which application we are be used. So based on that our applications, we are using that the thing for that is that the IO ports peripheral. And also we are built with the ADC, again the vendor which can be manufactured for instructions, okay, for reading, or that is reading of ADC. Not only ADC, some latest processor will also directly read the sensors. So we have the separate command, that is command. We have the separate command to read the ADC. Suppose if you are going to assume that is a processor for the automotive application. The application is automotive, which means automobile applications. We are using the CPU. So we have the separate instructions, used. Separate instructions we have going to be used for CAN operation. control area network. So that is CAN operation which can be directly be used, or if you are used in the number of sensors, so we need the number of IO ports for automotive applications, the automotive or automobile applications. If the processor are simultaneously used in the some other process for the different, so application based we are going to be design, that is peripheral set. Next one is that is the operating voltage. So this is a very important. See, nowadays that is the nowadays the latest technology, that is that operating voltage. Okay, operating voltage also which has the function of, that is speed. Nowadays the latest processor, right, the operating voltage which also a function of another, that is we have going to implement that the speed of the system. So how we are going to choose? Suppose nowadays we have used in earlier days for the 5 volt system. Next that is we are used for 3 volt system. So nowadays that is the 2.5 or 1 volt system also we are going to be used. This is latest. Okay, latest system. So if the voltage as like a turbo boost, I think you are buying that the latest process with the capable of turbo boost as like this, that is the based on that voltage level we are going to utilize. The maximum value is 12 volt, that is we are the sorry 5 volt we are well known. So something is a 3 volt or 3.3 volt, 3 volt or to 3.3 volt. Nowadays that is the that is 1 volt processor which can be available in the market which is available. So we are utilizing 1 volt or 2 volt for our control signal operations. So based on that requirement we are going, suppose if you are using the battery that is battery which is equal to ampere hour. At the same time if you are using the low voltage and higher ampere hour, that is the VA rating, total watts VA, that is R wattage rating will be increased. So that is the thing we are going to be consider. Okay, so what is the operating voltage we have used? Next, specialized processing unit. What is mean by the operation that is the specialized? Suppose please assume that is in processor MP, a processor having a some processors, which means basic, there is no multiplier. Yes, there is no multiplier operation. I think you are well known the 8085. But in the DSP processor, suppose if you are used in the DSP having that 8 and 16 bit, 8 and 16 bit, what is this? Multiplier. That is multiplier. And the DSP having a separate instructions for the convolutions. I think you have studied this operation convolution, and that is FIR and IIR. So FIR denotes finite impulse response filter, that is infinity IIR, similarly infinity impulse response filter. So these specialized operations, so these are all that the specialized operation, these are all the specialized operation which can be formed, which can be developed in the specific processor. Suppose that the processor which can be in the automotive field or automobile field, they are using the CAN network and other things. So here, please see. So that is the thing that is here we are seeing that concept of that that is IAR and FIR. So that is called a specialized function. That is the specialized function of the processing unit. The processing unit having a specialized function within the single clock. That is one clock. How many clock is required? That is the one clock. Assume that is which may going to do, that is one clock, single clock cycle which may going to do that these multiplications or this type of operations. So, separate inbuilt hardware equipment, the hardware that is build up block which is available inside the processor. So that is that the another thing we are going to be see, right? So this is the selection of that another process. Next one is the basic and the another thing, make a list of required hardware interface. This is another one. This is app based. Required means the required hardware means that is applications. Application. This is hardware. This applications based. Suppose what type of application used. Suppose as like here that is used in mobile applications. We need the compulsory. We need that that is a audio input. Next one is that is the number of video, that is videos input. So next one is that output touch screen. The touch screen input systems we need. What about that is the another operation, another types of USBs as usual. That is the number of USB systems output that is we need. So as like this number of things we have going to be considered. Same thing I am also going to be used in that that is the motor control. So suppose I am used in the motor control. So what is we need that is in three-phase system 3 plus 3 at least minimum, that is the 6 ADC input, and we have going to the higher range of multiplications. So hardware interface which is the PWM port. PWM port, because in the motor application, see please consider this, in the motor applications we need the converters. So converters or inverters. So minimum it having a 6 pulse. So 6 pulse we are going to produce separate things. So we need that the PWM port. So depends upon the hardware application, depends upon that the application we are going to be use, and it is the major point. Another one mobile is a communications. It is very important for requirement of mobile based processor. So the application based processor which can be the hardware requirement will also change. Next, examine the software architecture. So software architecture. So this is that software architecture means, so the basically we are going to see that in the whiteboard. So this is that the hardware which is available here, that is hardware. So that is a software based system. Again we are going to use in this about this that is the kernel, that is kernel based operations. So next that is the programs application, that is the programs, that is another programs. Next that is we have going to use this user based programs and user based apps. So we are going to directly touch this 3 point. We are going to touch this point. But here had software architecture. How? That is the software architecture. Here, that is the software architecture, which means that is the software architecture here, which means suppose I am going to write the program. I want to directly going to fetch the hardware, which means that is the com port. See, assume that is Windows 95, 98, XP up to 7. Some 7, latest version of 7 is something else different. You are directly that easy to fetch the COM port, but some 7 and 8, that is we are not easy to fetch. We are not easy to fetch the COM port. And another version, that is Windows 10, that is the Windows 10, which is not directly, which is not directly fetch that the COM port. So in between you may going to fetch this point, again the kernel will pass us again this is into the hardware. So this is due to security purpose. So this is for the security purpose. So this is we are going to consider based on that our applications, if the software architecture which is suitable or not for our applications. So that is the another one point. Okay, that is the another one point. Okay, next select the architecture. So this is select architecture. Normally that is the architecture, the basic thing, that is 1U1 architecture. That is 1U1 architecture. Next one is Harvard architecture. See, please pronounce Harvard. This is not a hardware. Harvard architecture. 1U1 architecture. So that is 1U1 architecture. This is hardware architecture. I think you are well known in the MUPI and MUSI. This is that is program bus and data bus is basic as. This is a separate program bus and data bus and control bus is a different thing. Harvard architecture and 1U1 architecture. So not only for this architecture, for in the DSP based applications, that is we are used in that hardware architecture. That is in the DSP based applications or some other operations, DSP based that processor, that is normally we are well known, that is the microprocessor, that is the input port. Then that is A register, which means ALU. Then it may be stored in memory, or it may be directly handled by the DMA or some other thing. This is conventional process. But in the DSP or specific application process, we are directly managing the data, which can be, that is the data, that is the input port to directly ALU, or sometimes that is the ALU register, which can be directly loaded into the data. So that is why we are going to this type. So reduce the latency, latency. Okay, so what is the thing is a example, sir. Suppose if you are going to consider, that is the so many project, IoT project, already I was told to you IoT project. So that is latency, that the IoT based control which may be implemented, and everything we are going to minimum of at least some milliseconds, 1 to assume that is 15 milliseconds will be taken. Suppose instantaneously, that is 2 seconds it will be taken for the long distance. But that is the PMU operation, which may be going to do in the less than 10 milliseconds. less than 10 milliseconds. So we are going to that is the measure the signal of voltage and current, and which may be going to transfer through into the satellite, that is this again return, then the relay will be operated. The entire process will be done within the 10 milliseconds. So that is the point we are going to be considered for the operations, okay, of the processor. So that is next one is that is the identify the memory needs. It is we are separate topic, is a big topic. Identification of memory is a very big topic. So that is suppose I have a program only in the code base. This is entirely based on the application. So my code application is only the low bytes. So I am also going to select the low ROM, that is, but my ROM is the very less low ROM is required, but during the running I need the large the high memory space. Then you can use the high RAM. My program code is low, but my that storing of that memory is in very large. Sir, how it is possible? What is this, sir? So assume the camera which can be that is reading, that is measuring and processing, the processing operation, that make the code is very less, the operation code is very less, but you are capturing the data, that is 24-bit, assume 24-bit. This is very much large data compared to this. And if you want image processing, if you want the image processing, the huge memory size is required. The huge memory size is required for the image processing. If you are going to do the image processing, that is the huge memory space is required, but the image processing code is very low, okay, comparatively. So assume, so that is the memory is not only for that the your program, your application based, okay. Next, start searching for the micro, that is the microcontroller and micro processor. These all the things we have going to be consider, then we can use how it can be implemented, how it can be implemented. So that is we, the above points are also going to be checked. Above points are also going to be checked, and then you can take a decision which type of that is what type of microcontrollers actually we need, okay. So that is the point. So the next one is that is examine the cost and power constraints. So application, if the if it is, that is the power is constraint is very important thing, right? Please note down if the processor in the power constraints. Oh, the item is very full. I am refreshing my canvas, right? Export quality. This is image 3, right? It will check, that is the time latency. Clear canvas, right? So that is please assume what we are going to be that is the requirement is a power constraints. So the power requirement, so what is that, the power requirement of the processor? It is a very important thing. First point, we are going to be assume that is the processing time. Processing time. Sir, what is mean by that? The processing time, which means that is ALU utilizations, or that is the CPU utilization. If the CPU utilization is increases, the power consumption of the processor will be increases. Please see. I am also going to open the task manager now in my system. Control Alt Del, right? I'm going to start now the task manager, right? So please use, that is that what is the CPU usage in the performance wise. If it is, I am also using that the utilizations and the CPU usage is 53% and 98%. If the CPU usage is increases, then the power consumptions will also going to increases. So if the CPU usage is very less, then the power consumption will be reduced by the processor. So what I am saying is, the very first point, suppose your program, that is the processing time, and the next one is, that is the process, process code, which means the program. Okay, so this program which can engage with the CPU, how long time, that is how long time. If the long time can be process can be working, then the power consumption is more, right? So based on your applications, you can design, you can choose the processor based on that the code, based on that code, how long time your code is running. Next one is handling, which means handling of IO ports. IO ports. Suppose the single event, example, single event, same digital pin, uh, digital pin used for up to low, that's all. At the same thing, that is the multiple on off. What is this? So that is on off, which is we are going to do in the PWM. Suppose PWM, the output pin, the output port pin, with pin is the number of times, that is suppose 1 kilohertz, 1 kilohertz, that is 2000 times switch on and off is there, 2000 times. So each and every time on off, it may consumes the more power. Please keep it in your mind. Okay, so if you are selecting a motor control PWM pin, which consumes the a large power, at the same time mobile which also comes the less power. This is power. So please, power consumption is depends upon your applications, what purpose you have going to be used. So that is the point we have going to be considered for the selection of the power requirement. Okay, so that is the thing, right? Power. So the power and cost, which also is interrelated. Why it is interrelated, you will see. So that is already I am says, that is the battery power, that is the power, the how much of watts is required. So the battery normally says that is Ah, ampere hour. How long, that is how much ampere which can be supplied the how long time, that is then only it is called. And also we are going to be based on the voltage, suppose the 5 volt. Based on the voltage we are going to taken as in terms of watts for our calculation purpose. Okay, so if it is, please keep it your mind. In my processor which can be consumes that the that is assume that is 10 watts, assume that is 10 watts, it's a 5 volt. It may going to taken as that 2 amps, that is 5 volt and 2 amps. My process which can be run in 2 hours, 2 hours. So what is this? So ampere, so 5 volt. I am also going to take as 2 hours, 2 plus 4. So a minimum plus of at least 50 percentage of your usage time will be added. Then 5 Ah, 5 volt battery is needed. But I have the drive circuit and another PWM control circuit, the same 5 volt. That is that I am also the process which can be run in only that the 30 minutes, 30 minutes. So what is that the time is required? The 1 by 4, I think 1 ampere hour, 1 ampere hour battery system is enough. 1 ampere hour battery system is enough for the operation. So what is the price for that is cost for this is the cost for 5Ah and 1Ah. So the processor application, what type of process, we everything which can be incorporate the operation of that the examine the cost thing. Okay, so next check that is the part is availability. It is very important thing. Suppose one new MP or MC microprocessor or microcontroller which is available, which may suitable for 100% suitable for your applications, 100% suitable for applications. At the same time, due to some bug it is available, it can be stopped or vanished in the market of 1 year, 1 year. Then what is the use? You are not able to that is the retrofitting, or it can be servicing your equipment. The market liability, it is very market reliability is very difficult for that part availability. So if you are choose one product and work in the product which is minimum, you can select the process and then choose one processor. Your hardboard design will take 3 months time. The product will also come up to 10 months or 1 year. At the end of the 1 year, the vendor which can be stopped to produce the processor, only the produced processor only it is available in the stores. Then how your product you may going to sell, again you may going to do the R&D for this part. So what is this 6 plus 3? At least 6 months. 6 months R&D you may going to repeat. So this is very tough for you, right? In the market or company based systems. So what we are going to do is select that is the whether the part is availability for the continuously you can take, and then you can do the as per the requirement. Okay, what is this? Yes. So next that is the select the development kit. So that is this is the select the development kit. So this is if you are buying the processor, you have the development kit, that is the suitable development kit, that is uh, working for learning process, for learning. Development kit means development board, we need. So otherwise you can't properly learn, and it can be frequently available in the market, that is a the another thing for the development. Next, investigate the cross compilers and tools. This is very 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 important, because you may going to maximum run, run in the C language. You can run in the C language or any high level language. You need the proper cross compilers to implement your developed code in the specific latest processors. Otherwise it may be difficult. If it is any bugs it is available, it may be difficult to implementation. So that is the processor which can be used in the sessions. Once again, that is that the thing we have going to be used or considered for the selection of processor. Okay, please be considered again. So that is here, I need the processor, uh, I need the processor. So what are the things I am also going to consider? What is that bit size? Next one thing, so if it is bit, next that is the speed. Next, what is that? The IO port. What are the IO port? So next one is the fourth one. The fourth one is memory. What is the memory which is available? Next one is, that is the power requirement. How much of the power requirement? Next, special IO ports. Next one is, that is the another one thing I am not tell, but now I am going to tell, that is operating temperature. Suppose if we are used in the military application or some other application, it may be going to withstand 50 to 70 degrees Celsius also. So that is the thing we have going to be used, that what the things. So next one is any special functions, like what is this? FIR and IIR. As like that, the FIR, IIR are can, and another things we have going to be consider. Next, we are going to consider the that is the processor speed and cost. So that is the cost we have going to be utilized in the system. So next, that is that the architecture, that is architecture. So next one is, that is the constraints. If it is any constraints for memory, or another one things, the thing is used as the cross compilers. Okay, cross compilers. So these are we have going to further improve the points. So first of all, once again I am going to conclude each and every point. The processor selection, that is the processor selection. So bit size, bit may be 8 to up to 64 bit size processor which is need, depends upon our requirement. So next, this is the speed. Up to our processor nowadays, the 600 megahertz 600 megahertz for the micro 10C processor, which is available, single core or dual core processor, that is in the architecture. So that is the 600 normal. This processor up to 4 to up to 6 gigahertz conventional processor, which is also available in the market, then which is used in the IO ports, different types of IO ports, that is different types of IO ports is which is available port. Next, memory, type of memory, and how much memory, what is the size of memory, type and size of memory we are used. Next, power consumption of the process, power consumption. So next, the specific IO port which is available or not, as like the that is PWM operations which is used. Next one is operating a temperature, whether it is used in the what type of, where it is we are going to be used. Next, we are going to be using the special functions like input, the finite impulse response filter, infinite input response filter, as like that is the DSP based operation. The next, convolutions or any can operation or anything we have got a special. Next one is that the cost, which is how much cost of that processor. Architecture means which is increase also, that is the single core or dual core, or that is multi-core operation. So the architecture is single core, dual core, or multi-core operations. That is the any constraints of that memory or limitations of the processor, so which can be work in this environment, that is environment, or any constraints operating temperature based, or any other constraints which is memory or programming, or programming structure, hardware structure, any constraints. Next one is whether it is the cross compilers, and I see the in circuit, that is ID, integrated development environment, in circuit emulator, and debugger or integrated development emulator which is available or not. So these are all the things we have going to select the points you are considered for the selection of processor. Okay, now do you have any doubts? Okay. So up to this, yes, tell me.
The cross compiler, sir.
Yes, cross compiler, which means yes. We will see. No problem. The cross compilers. Um, just I'm going to. What is this? Yes. Please wait. Yes. Here, that is the oh, sorry. Okay. Cross compilers. So the cross compilers, you are well known the middle level language. Nowadays, high language C is act as a middle level language. You are only the language for the human, assume for explanation purpose. Now, Intel having a some processor. Okay, Intel's having a some processor, Motorola having a some processor, TI, Texas Instruments having a some process, right? So please keep it your mind. That is Intel, Motorola, Texas, then microchip, which is named as, that is PIC, PIC microcontroller having. Next one is NXP semiconductor having a processor. So assume all processors that have that 8 bit, no problem. Almost all are the speed is close, and other characteristics, but the thing we are going to Texas and Intel having a cross compilers, but that is the NXP having a different cross compilers. So the cross compilers, which means each and every company having a separate processor. So what is the function of the cross compilers? C code into machine level language, which means how it can be run. It may be converted into the Mnemonics converted into, that is what I'm says, that is instructions code. Already you are well known this code, op code. This op code which can be converted into x bin. So I am also giving, if I am going to develop one processor, if I am vendor of Intel, I am vendor TI, or I am vendor PIC, I am vendor in NXP, I am vendor in Motorola. I am also publish the cross compiler. That is the cross compiler. That compiler which may going to convert the C code into this xbin executable code. Otherwise, if you are going to study all the instruction architecture, otherwise without C compiler, you may going to write in terms of ASM, assembly level language. Assembler and assembly language. It is possible to study the Intel, Motorola, TI, PIC, NXP, all the microcontrollers. It is possible for practically.
Difficult, sir.
It is difficult. So for that purpose, if I am going to develop one microcontroller, simultaneously I am going to develop one cross compilers. So, and I am also going to publish at the same as microcontroller launch. Whenever I am going to launch my microcontrollers, so 8-bit microcontroller, simultaneously I am launch the cross compilers. So the user which can be easily utilize my processor, my product, or my microcontroller. Okay, are you able to understand? Hello, are you able to understand the concept?
Yes,
Yes.
sir.
Oh, okay. So
Yes, sir. Yes, sir.
okay, thank you. So up to this, please wait. Now I am going to stop my recording.